Hello everybody, it is me. And today we're going to be learning counting and probability tips and tricks um, for math competitions. So for AMC 8, for math counts, for AMC 10, A and B. This is relatively simple. It's not going to be incredibly advanced, but that's kind of the point of counting and probability is that it's hard, but it's also it's hard to simplify it is essentially. Like there's a lot of ways that they can make it brutal, but then you simplify it, and that's the whole point of it, and that's the beauty of it. So this is going to be part of a series in which I do tips and tricks for competition math, which include algebra, geometry, number theory, counting, probability, and pre-algebra, but Grape might do that one. Okay. So, and then be sure to check out our other videos. I think, yeah, boy, what's his name? Chamgus is uploading docs, is making a series on algebra, which might be kind of cool if you're stuck on algebraic topics. Let's begin. Counting probability tips and tricks with, what's my name? Chief. Chief is my new name. Okay. So, let's start with what counting and probability is. What is it, right? You have essentially, okay, so counting, let's start with counting. Oh my god. Okay, wait, I better actually use a keyboard for this because I need to, oh wait, no, there's an undo button. Okay. I'm still getting used to this. All right. Let's start with counting. Oh, let me create a new layer. See, look, I'm just too good at this. Okay. What is counting? Well, it's kind of in the name. It's where you count a certain number of objects, right? And this leads into probability. I will show you how, but let's start with counting. So let's say we want, let's start with very simple, like counting lists. You can create lists in many ways, and it's quite useful. Okay, so let's say we have a list 1, 2, up to 35. How many numbers are in this list? Well, obviously there's 35, right? If it goes on 1, 2, 3, 4, blah, 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 right? So there's 35, okay? Oh, wait, let me zoom in, actually, and just write all this stuff. Ooh, wow. Okay. 1, 2, 35, right? And then there's 35. Let's do a bit harder, right? Let's go 5, 6, 2, 47. How can we find how many numbers are in this set? You can count them all. That's not a very smart idea. However, you can. But another way to count lists. This is basically, I mean, this is basically the heart of counting lists. Is you want to turn it into a list which starts at 1, goes 2, 3, up to whatever number you want, right? That's the basis of what you want. So how can you turn 5, 6, 7 into 1, 2, 3? Well, obviously, if you subtract 4 from all of these numbers, you get 1, 2, 3, right? But you're not changing the number of numbers in the list. You're simply changing, you know, what is in the list. I better go faster. Oh, jeez, this is 4 minutes. Okay, so let's do that. Let's subtract 4 from all of these. Okay, so we get 1, 2, up to 47 minus 4 is 43. So we find that there are 43 numbers in this list. Let's do another one in the counting lists section, and then we will move on. Well, kind of. Okay. Let's go, how about this? How about 3, 6, dot, dot. How about what? 51. Right? So how can we do this? Well, how can we turn 3, 6, 9 into 1, 2, 3? Well, we divide by 3. Once again, dividing by 3 doesn't change the number, which is what we're trying to find, of numbers in the set, right? it's simply changing what the numbers are. It's not changing the actual number of numbers. So let's divide all of them by 3. We got 1, 2, 51 by 3 is equal to 17. So we get there are 17 lists. 17 numbers in the list. Now let's combine two of these things. Oopsie doopsie. Right, let's go 8, 11, up to, how about 104. Okay. Let's think, how do we approach this? Well, let's find the common difference. It's 3, right? 11 up to 14, 3, right? So our common difference is 3. Therefore, we want to get it into the form 3, 6, dot, 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 and then we want to divide by 3, right? So let's think. How can we get it from 8 to 3? You subtract 5. Let's see if that works with 11. 11 minus 5 is 6. So that does work. So let's subtract 5 from all of them. It's not changing the value. So 3, 6, up to 99. Then we divide by 3. And we get to 1, 2, up to 33. And so that's that's a way to count lists, is you use, you basically manipulate the list so that you know what's happening with it. And yeah, that's super useful. So let's move on from counting lists to finding sums of lists. So let's say we have a sum from 1 to up to, how about 12, right? And there is a formula for this. It's using the triangle numbers. So it's the number, the last number, times that number plus 1, and divided by 2. There's tons of proofs for this. I'm not going to prove it, but that is the formula. And it works for anyone. Try 3. 1 plus 2 plus 3 is 6. 3 times 3 plus 1 is 12. Divided by 2 is 6. It works for all of them. Okay? So 1 to 12, if we're summing them, we get 12 times 12 plus 1 over 2. 6 times 13 is 78. Right? Now let's say we want to find the sum of 4 plus this is one way to do it. It's not the best way, easily, but yeah, we're trying to work off of what we have to give you a better understanding. Up to how about 15? Okay. Now this one is quite simple. You can simply oh no, I've watched that completely. Oopsie. Okay. All right. Let's erase this. Oh geez. Okay. 4 plus 5 up to 15. How can we solve this? Well, one simple way, if you're super confused on arithmetic sequences, which I will talk about eventually, and what you do with them, and this is an arithmetic sequence, and you can easily solve this way easier with said arithmetic sequence. But let's see how we can work with this. Okay, let's say we subtract 3 from all of them, then we get 1, 2, up to 12, right? And you think you just add 3, but you're adding 3 to all of these terms, right? So you're subtracting minus 3 times the number of terms. Well, what's the number of terms? Well, 4 to 15, let's use our strategy, subtracting 3. There's 12 terms, right? Sorry, you're adding 3 because you subtracted 3 and at the start. So, okay. So you subtracted 3 times the number of terms at the start, so then you're going to want to add them in the end to cancel it out. Right, so the number of terms is obviously 12. You can use your strategy. Subtract 3, so you get 1, 2, up to 12. Right, so the sum of this is 78 plus 3 times the number of terms, which is 12, so plus 36. 78 plus 36 gets us to 114. So that was kind of how to count lists and how to sum lists. Hopefully that was a bit helpful. Now that's one part of counting. And so what I'm doing with counting probability is I'm teaching you one strategy of counting, or two, and then one strategy of probability. So obviously our counting strategy is done, so let's get that out of the way. There we go, look at that. Okay, now it's time for probability. This. Okay, oh boy, probability, where do I even begin? Well, obviously we begin at the start. So, what is probability? It's the chance of something happening. So if I roll a dice, it's a chance that I get a 6, right? If I roll a dice. It's a chance that I get a 6, right? Okay. Let's begin. So how do we do this? Well, a dice is obviously, there's an equal chance of getting all of them. So you have 1, 2, 3, 4, 5, 6. Right? There's an equal chance of getting a 1, a 2, a 3, a 4, a 5, or a 6. What's the chance that I get a 6? Well, let's call this, okay, so the chance of something, the chance of, how do I explain this? Okay, so the probability of me me flipping a coin and it getting heads or tails is 1 in 1, right? So 1 out of 1, which is 1. So the probability of something guaranteed to happen is going to be 1. Does that make sense? Hopefully it does. So let's call the probability of rolling any of these numbers, which is all equal, x, right? So this is x, 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 and x, right? Now, what's the probability that I get any of these numbers? It doesn't matter which one. What's the probability that I get a number when I roll the dice? Well, obviously, it's going to be 1, unless you live in a cursed world, in which case this is irrelevant. Okay, so the probability of getting any of those is 1. However, the probability, because they're all equal probability, we're going to have to divide it by the number of chances. Okay, so let's begin, right? And then, so let's call this probability, how about 1 over x? Right? Instead of x. So 1 over x, okay? Oh my god, that looks like 3 over x, 4. Ignore that. 1 over x is the probability of rolling a 1, a 2, a 3, or a 4, or a 5, or 6, right? So if we sum all of these probabilities, then we're obviously going to get, well, there's 6 of them, so 6 over x equals 1, right? Obviously, if you have a number over if you have a number over another number equal 1, obviously the numbers are going to be equal. So 6 over 6 equals 1, so x equals 6, right? X equals 6, but 1 over x is probability. So we have 1 by 6. It's probability of getting any of these, so it's 6. I mean, 1 by 6. Hopefully that makes sense. Another way you can think about it is you have 6 so you have 6 ways to pick a number that's going to happen. And out of those, there's one way to have a 6. However, this doesn't make sense if you don't know about probability. There's 6. Okay, so let me explain this. So there's 6 ways to choose a number, right? And out of these 6 ways, there is one of them that gets a 6. And this only works if the probability of each thing is equal. And obviously these are all equal. So you get 1 in 6. So so that's the basis of probability. Another way to think about it is if you have any problem, it's asking for the probability of something happening. If you don't know how to approach it in a better way, do this. You have n over d, right? Numerator over denominator. The denominator is going to be the total number of ways that this thing can happen. N is going to be the total number of ways that work, right? Work as in they satisfy the condition. So for example, let's say we're flipping 3 coins, right? What is the probability that none of them come up heads? Okay, so let's think, how many ways are there for me to flip these 3 coins in a different way? Well, I mean, coins, heads and tails. They have heads and tails on top and bottom. With probability that none of them flip up heads. There is 2 ways to flip the first coin. And then for each of those 2 ways, there's 2 ways to flip the second coin. For each of those 2 ways, there's 2 ways to flip the third coin. So we get 2 times 2 times 2, which is 8, as our total number of ways, right? What is the and then, okay, so let's think. How can we have no heads? Obviously, all of them have to be tails, right? So we have tails, tails, and tails. Obviously, there's one way to have tails for each of them. 1 times 1 times 1 is 1. So our probability that we get no heads is 1 divided by 8. Would you look at that? That is the basis of both counting and probability. That's not really a tip and trick. This is kind of an intro to this world of counting probability that is used incredibly often in math competitions, and that they did like next episode is going to be really where the real tips and tricks start. If you don't know about counting probability, this is the place to go. Thank you, and hail grargrgregon.